Hey, we have here today on the board another integral from the MIT Integration Bee. This was from 2023, regular season, problem number 1. We have the integral from 0 to 2 pi of the max of sine x and sine 2x dx. Okay, I thought this was pretty interesting, not too difficult. So maybe we're not that used to having the max function inside the integral, and I thought maybe the best way to handle this was with a graph. And so I took my time here and tried to get a decent enough graph on the board so you guys could see what's happening. But what I did was I wanted to graph sine of x first, and I graphed sine of x in black here. And then we have in red sine of 2x. Because we're asked for the max here, it's going to be easy to see what the max is in different regions on this graph. Now we do have these intersection points, like right here, you see these are going to intersect, and this point here is going to be at pi over 3. And then we have another intersection point here, which is clearly at pi. And we're going to have one more intersection point here. This point right here is at 5 pi over 3. And of course, we're going to have the endpoints at 0 and 2 pi. And what I'm going to do is break this up into a bunch of different regions because we have different max functions depending on the area we're in. So like to start with, I'm going to start from 0 and we're going to go to pi over 3. And from 0 to pi over 3, we can clearly see the max is always going to be here with our sine 2x function. So from 0 to pi over 3, we're just going to integrate sine of 2x. And then next, I'm going to start at pi over 3. And we're just going to go to our next intersection point here at pi. And then here, the max is going to be the black function, which is sine x dx. Sorry, correction, I totally wrote this wrong. So let me just redo this. So the intersection point is right here. This point over here is actually 3 pi over 2, but this intersection point, I did write the right value, which is 5 pi over 3. I just put it in the wrong place. So this intersection is going to be 5 pi over 3. And so for our next integral, we're just going to be integrating from this intersection point pi to this one, which is 5 pi over 3. And then here, the maximum value is going to be the red function sine 2x. And then for the last one, we're just going from 5 pi over 3 to the endpoint, which is 2 pi. And this one, it's going to be the black function sine x dx. Okay, and the nice thing here is we have all easy integrals, and we're actually only just integrating two different functions. So this is going to be pretty easy. So starting with the first integral, we're going to integrate sine 2x, and we're going to have minus cosine 2x over 2, and we're just going from 0 to pi over 3 for that one. Then next integrating sine is just going to be minus cosine of x, and that's going from pi over 3 to pi. And then here, this is going to be the same thing as this one, right? So we're going to have minus cosine 2x over 2 from pi to 5 pi over 3. And then here, just again, minus cosine x from 5 pi over 3 to 2 pi. Okay, so now to finish this off, we just need to evaluate this thing. So first I'm going to plug in pi over 3 here. Cosine of 2 pi over 3 is going to be minus a half. Minus a half over 2 with a minus, this is just going to be 1/4 right here. Then when we plug a 0 in, we get 1 minus a half, but minus a minus half is going to give me plus 1/2 here. Then next plugging pi in here, cosine of pi is minus 1 times minus is going to be a plus 1. Cosine of pi over 3 is going to be 1/2. We have minus a minus, this is going to be a plus 1/2 right here. So plugging this in here, cosine of 10 pi over 3 is going to be minus a half divided by 2, but with a minus, it's going to give me plus 1/4 here. So plugging in a pi here, cosine 2 pi is 1, so we're going to have 1/2 minus, but another minus is going to give me a plus 1/2 here. And then for this last one here, plugging 2 pi in, cosine of 2 pi is 1, but we get the minus sign, so we're going to have a minus 1 here. And then plugging 5 pi over 3 in here, this is going to be a plus 1/2, minus sign here, but then another minus sign is going to give me a plus 1/2 here. Just adding this up, I see that we can cancel this minus 1 with the 1/2 and 1/2. 1/2 plus 1/2 plus 1, this is going to be a 2. So we have 2 here plus a quarter is going to give me 2.5. Or for our final solution, I'm going to write this as just 5 over 2. Okay, so I think you can see the integrals were really pretty easy, and this was a pretty straightforward problem, but we just had to be really careful with adding everything up and with the graph. So we'll stop it there. Thanks everyone for watching today. Have a great day.